To begin your titration, using a pipette filler and a volumetric pipette, measure out 25 cm cubed of your solution with an unknown concentration and add it to a conical flask. In this video we are using hydrochloric acid. When inserting the pipette into the pipette filler, hold both pieces of apparatus near the ends closest together to prevent stick injuries. Once you have measured the correct volume of solution, remove the pipette filler and allow the solution to drain into the conical flask. Add several drops of indicator to the conical flask. In this video we are using phenolphthalein, which gives a clear, colourless to magenta colour change on neutralisation, but you could also use other indicators such as methyl orange. Next, ensure that the tap on your burette is closed, which is when the prongs on the tap handle are in the horizontal position. Now we need to fill the burette with a solution of known concentration. In this video we are using sodium hydroxide solution. Place a filter funnel into the top of the burette and move the burette so that the top of the funnel is either at or below your eye level. It is unsafe to pour liquids above where you can easily see. Now, slowly and carefully pour the solution of known concentration into the burette, filling the burette to around the 0 cm cubed mark. Don't worry if you fill the burette too much, as we can correct this in the next stage. Open the tap on the burette by turning the tap handle to the vertical position and let some of the solution drain out into a beaker. This is to ensure that the part of the burette below the tap is also filled with solution and allows for accurate readings to be taken in the next stage. Once you have filled the end of the burette, then close the tap again by turning the tap handle to the horizontal position. We are now ready to begin our titration experiment. We will begin with a rough titration, which will give us a ballpark to guide our more accurate titrations later in the experiment. Begin by taking an initial volume reading from the burette. You are looking for reading the value for the bottom of the meniscus of the solution as indicated by the arrow in the video. When taking burette readings, they should be to 2 decimal places, and the second decimal place value being either a 0 or a 5. In this case, the reading is 2.50 cm cubed. Note this reading down in an appropriate table for later use. Open the tap on the burette and let the two solutions mix and begin to react. Keep swirling the flask and close the burette tap when the colour in the conical flask has completely changed to indicate that neutralisation has occurred. A piece of white paper or a white tile can be used to help distinguish when the colour change occurs. In this video we stopped when the phenolphthalein turned from colourless to completely magenta. Take a final volume reading from the burette for the rough titration. Again, take your reading using the bottom of the meniscus and record the value in your table. In this case, the reading is 28.30 cm cubed. Now we will complete the actual titrations. Start by thoroughly rinsing out your conical flask and refilling it by adding 25 cm cubed of the solution of unknown concentration and several drops of indicator. Top your burette back up with the solution of known concentration and take a new initial volume reading from the burette. In this case, the volume recorded was 4.90 cm cubed. Now, carry out your titration experiment again. Run the solution from the burette while swirling the conical flask. You can let the solution run quickly at first, but close the burette tap when you are approximately 2 cm cubed away from your expected endpoint based on the results of the rough titration. At this point, you want to add the solution from the burette to the conical flask dropwise. Add 1 drop from the burette, close the tap again, and give the conical flask a good swirl. If a colour change occurs which is not permanent when swirling, then repeat this dropwise process. Stop adding drops of solution from the burette when the colour change is permanent. 1 drop is all this will take, so be careful. Take a final volume reading from the burette for the first titration. Again, take your reading using the bottom of the meniscus and record the value in your table. In this case, the reading is 30.50 cm cubed. You will now need to repeat this titration experiment again several times until you obtain results for the titer volume which are concordant. Concordant results are those which are within 0.10 cm cubed of each other, ignoring your rough titer. We will now go over how to calculate the mean titer for your experiment. First, we will set up our results table to show the initial and final burette readings and the titer volumes for each titration we performed. Begin to add your results into the table. Based on the 2 readings we took for our rough titration, we obtained a titer volume of 25.80 centimeters cubed. Then, continue to add in your results to the actual titrations you performed. Actual titer number 1 is the titration performed earlier in the video, and titers 2, 3 and 4 were performed off camera. To calculate the mean titer for this experiment, we will need to use the results which are concordant. Also, we always ignore the rough titer from any concordant results, as due to the fast nature of the practical, we cannot be sure of the accuracy of that result. We can see that the titer volume for actual titer number 3 is considerably larger than those for numbers 1, 2 and 4, so we will not use this result in the mean titer. The titer volumes for actual titers numbers 1, 2 and 4 are all concordant, being within 0.10 cm cubed of each other, so therefore we will use these titer volumes to obtain the mean titer for this experiment of 25.60 cm cubed. This is the value you will use to help you calculate the unknown concentration of the solution that you placed in the conical flask.